Everybody. It's 5 o'clock on Tuesday, which means it's time for math. Welcome to another edition of our Tuesday Facebook Live math sessions. My name is Jeremy Jasper with KathleenJasper.com, and I'm glad to have you in for the next hour to do all things math for your teacher certification exams. Just like we do every Tuesday from this time, I go over 10 problems that will help you out on your teacher certification exams. I'm here to help you with any tips, tricks, anything that I can provide you with so that you will do your best to pass these math exams. I know they're frustrating. I know they're challenging. I know they're a pain in the butt for you to do, but the goal is to ultimately get through this, get that passing score, and then finally get your certification. So for the next hour, I've got 10 problems that I'm going to go through. If you're watching us on Facebook or YouTube live, then go ahead and comment below if you have any questions or any concerns or need me to re-explain something to you. This is also recorded, so a lot of you watch it on the restream. And if you have any questions, you can always put it in the comment section or you can send me an email. So I'm going to go ahead and just make sure I'm all up, ready to go and loaded so that you guys can get your stuff situated. Again, like I always say, make sure that you have a calculator handy. Try and figure out what calculator you have available to you when you take your specific test. And then also make sure that you have scratch paper available to you. I talk about the scratch paper all the time, only because it's important that you understand you only have that scratch paper to work with. When you're studying with your workbooks, or if it's a piece of paper, or if it's anything along those lines that you use as study material, you're used to writing underneath the problem and you're used to using the space right underneath the problem, highlighting the text in the word problems. And you've got to be careful with that because you don't get to do that on a computerized test because you can't write on the screen. So make sure you have your scratch paper and your calculator, and we are all set to go. So let's go ahead and get these first problems up onto the screen. And a lot of people will ask, well, is this for a certain test? It's not necessarily for a certain test. I know this week I've got a lot more on elementary education. So K through 6, Praxis 2, all sorts of elementary education exams. These problems are taken from exams like that, similar to that, similar specs, and different types of problems along those lines. So, all of these sessions will help you in one way, shape, or form. Math is math. Math is universal. When you get to really hard problems, as you start stepping them down and you're right about to solve them, everything is always going to be some type of algebra involved, and you need to know how to do the algebra for these exams anyway. So anybody will always be able to take anything out of any problem that I have on these sessions. Okay, first one says, which of the following figures does not have point symmetry? Basically, here's what point symmetry is. If I take a point, and it's usually right in the middle. So I'll use this one as an example. Okay, and is this shape symmetrical? So with this point here, if I were to draw this line just like this, okay, do you see how this and this would go on top of each other, and I can fold them in, and then that would be symmetrical? All right. Same thing with this shape here. If I were to take a point and I were to do it like this, well, I could fold this over to here and this over to here, and they would match up on top of each other just like that. Okay. Same thing with the sun here. There's a point. So can I do this in a way that I can make it symmetrical? Absolutely. The only one that does not have point symmetry is going to be this one, because we can go along different lines. So some would argue that this is symmetrical, which it is, but then if I turn it, okay, problem is if I turn it, it's got to be symmetrical in all ways. If I turn it like this and this will not match up on top of each other. So somebody asked me this question, they sent it in, you'll see, point symmetry. Sometimes we don't refer to it like that, point symmetry, but it's basically, are these shapes symmetrical? So is there a process where you can fold them on top of each other more than once? And that's where this comes into play with the arrow, okay? Because even if I turn it, I still can't do anything with it, okay? So think of a center point and then folding it on top of each other. A is going to be the correct answer. All right, this one I get a lot of questions for. And it says, what is the equation of the surface area of the object? And so we look at this object, we have this square, its dimensions are A, B, and C. And each of the answer choices, just so you know, this is AB, this is multiplied. This is times AC times BC, okay? So what do we know of surface area? Surface area is going to find all sides, the area of all sides of this shape. If it's a cube, I'll just make it easy for us. If it's a cube, that means if I were to unfold this cube, you see how I have 6 sides. If I were to fold this up, I'd get the cube, right? And each of these dimensions, I can just make this A, I can make this B, and A, B, and this one would be C, just like that. But don't worry about that. I'm just trying to illustrate how you can get this from the 3D shape. Ultimately, what you need to know is we need to find all areas of all sides. The way that we do that is we're going to put them all together. So in this equation, if I have multiplication here and multiplication here, multiplication doesn't do me any good because I need to add all the sides. Surface area is take the area of one side, add it to another, add it to another, add it to another. There are formulas for it, okay? And, the most common one is, okay, base, what is it, length? Oh, shoot, I just had it. Oh, God, it just slipped me. Either way, if it's multiplication, it's not going to work out because there are different faces for each of these sides. And so because of that, I got to put them all together. You don't multiply these in one thing, right? This is a rectangle. I would do, I would do base times height, right? Base and height, base times height gets it. But once I start adding more onto it, base times height doesn't cut it anymore. So we have to take the individual areas of each face. So I'm going to have to add these things. Well, how many faces are there? Let's just take this for example. This is A right here and B. So if there's a cube here, there's 6 sides. This would be 1, and then there's 1 on the other side over here, right? Because I would draw it like this, and then I would come together like this, and then like that, right? You see how that would be, there's 2 sides. So there's gonna be how many pairs of sides for each of these? If 2 sides are always the same and there's 6 sides total, there's gonna be 3 pairs of sides. So A times B is 1, but then when we multiply it by 2, we get that. Then we got to do the next set of sides. Well, let's just, for illustrative purposes, give you a different color. So now, what if I want to do this side here? and that becomes BC. So add the area of BC, but how many BCs are there? There are 2. And then now the bottom, and I'll just circle these right here. The bottom makes up A times C. So A times C, and how many of those? There are 2. So see how there's 2, 4, 6. There's 6 total sides in the cube. And that's where I get my 6 sides. Looking at answer choice C matches up nicely for that. Okay. Why would it be all squared and would it be part of count sides? Okay. I'm looking at the question in the comments. Why would be all squares and would it be part of an example or any formula to problem 2? The only reason why they give this to you as the formula is because this, if you looked up formula for surface area for a cube, this is the standard formula for it. It's basically telling you find there's 6 sides, and because it's the cube like it is, it can be a rectangular prism, but it doesn't matter because you're doing all of the opposite sides. There's 2 of them, right? And there's 3 pairs of those. So that's what's going to get you the surface area all in one shot. That's the only reason for this problem to exist. Otherwise, they're going to give you a problem with the cube or the shape and actually give you dimensions and then have you find the actual surface area. So those are the 2 ways, because surface area is a competency on your elementary education exams. And so this is a way for them to assess it. Okay. But C is the answer. Just know that there are 6 sides, and with those 6 sides, opposite sides are the same. So you split them up, divide it by 2. That gives you 3 pairs of sides. Okay. Here's the next one, and I like this one. I'm going to show you why I like this one in a second. It says a cold front arrived at 12:05 a.m. and the subsequent temperatures were recorded in the table shown. If X represents the number of hours after 12:05 a.m., which of the following equations best represents the change in temperature as a function of time? So I'm going to show you how to do these problems quickly, but you've got to be observant. I've told you before, and we've gone over, you can go into previous sessions, but I usually have these types of find the equation problems a lot in my sessions because you're going to see them, and practice makes you better at solving these without taking a lot of time. So quickly, usually, I say usually, it's not always like this, but for the most part, it's done, the equation is done in the slope intercept form, where M represents your slope and your B represents your Y intercept. So let's concentrate on slope for a second. We have our time. So our time is, it's 12:05, 2:05, 4:05, 5:05, 6:05. Okay, that's fine. Usually they're done like this, whether it's top to bottom or left to right. This is your X value and this is your Y value. Okay. So given that we have our Y values here, that's what our equation would be equal to. But I want you to focus on the differences between these. Okay. So the differences between your Y values are going to be your slope, just straight up. If you look at these charts right here, the difference in your Y values are going to be your slopes. So I see 67 to 60. So usually we take the first 2 boxes. Just that's how we go through a lot of these things. We like take the first 2. I look at the first 2, and that's what I have. I'm just telling you through experience and tutoring many students. And when we confront problems like this, they can be overwhelming. So we just try to go for the easiest way possible. So we take this 2 and I see, okay, from 67 to 60, I see a difference of 7, right? That's 7. So that means my slope is going to be 7. Now, as we look at our answer choices, because our answer choices should always guide us. I see 3.5 and I see 7.1. Well, when we go back, this one says which equation's best. This word right here, I know I'm marking this problem up a lot, but this word here, best allows us to have a little bit of leeway for our slope here, okay? And because we're kind of like estimating, so that's okay. Use estimation often during your exams. You don't have to get the exact answer right when you do your work. I know that sounds crazy. You just have to be close, because you have to find the answer choice that is closest to your answer, okay? So let me just get rid of this. So that's why I see it's 7 here. So I would go through and I say, oh, 7. And then my y-intercept, well, it says it started at 12:05. And if all of these, here's another clue here. If all of these say 67, well, then I know that 67. And I know that because 67 represents my 0 point, right? Y-intercept is when X is at 0 and your Y is your point. Okay. So on a graph, right, our time 0 is like 12:05. That's what it would be. Okay. And then it would go up every whatever. Okay. And then that's what you would have. Or I'm sorry, 12:05 would be here. But it's not, it doesn't matter. Okay. It would be like right there, right? Because that's the starting point. That's the start of that cold front. Again, don't worry about it. I'm just saying some people are visual. So that's why I wanted to point out that's where the y-intercept is. So now that I have this here, right, I've got my 7 and my 67, I would go and I would pick one of these equations. But here's what I want to recognize. I went through all that and I'm going to say to myself, just doesn't look right if I looked at all the chart the same. So I'm going to erase all this because there's a lot of stuff on the screen. What you need to do is you need to be very careful when you get these problems. You need to look at the charts and you have to make sure that they don't confuse you. All right. The reason why I want to point this out is because this goes, so cold front arrived at 12:05. Subsequent temperatures recorded in the table shown. If X represents the number of hours after 12:05, so hours, that's like 1 hour, 2 hour, 3 hour, 4 hour. I've got 12:05 here, and then I got 2:05, 4, 5, 6. See what I'm missing? I'm missing my 1:05 time. So I have to be careful that this right here, I don't just subtract and get my 7, right? Because this is 7. But then the difference between this one is 60 to 53. Again, that's where's my 3:05. I can get, what is that? And again, see how this is 67 to 60, so it's going down. And then 60 to 53, that's 7 here. And then when I get to here, the difference is, what is it, 3.5, right? 3.5. You have to understand that this was by the hour. This right here, that's a 2 hour time. And then this is a 1 hour, 1 hour, 1 hour. Equations are done by your slope. It's 1 hour, 1 hour, 1 hour, because that's what it was set at. So if you're doing it like this, where you're finding the difference, you have to be careful to go ahead and go by the actual hour and not by each one of these data points that they give you. All right. And because of that, you just have to be careful that there was one here. So this would be 67 and 60. We'll cut that in half and it should be 3.5. So let me just see, 67 minus 3.5. That would be 63.5 here. then that gives you the 60, and then it goes so on and so on. So this is not a slope of 7, it's a slope of 3.5, like that. All right. And so now, if it's 3.5 and we know it's 3.5, let's start looking at our answer choices. And our answer choices are giving us a slope of 3.5 here and a 3.5 here. The 7.1s are gone, so I can get rid of them. So now what do I need to do? What's the difference between a negative slope and a positive slope? Well, think about it. Negative goes up, negative goes down, positive goes up. What's happening to these temperatures? And that's why you should don't necessarily focus on the equations, because I feel like if you separate your mind from the problem, like what's happening in the problem, to just strictly doing the math, you won't catch it. And the way that you catch this is it's a temperature. And think about it, that's something that's real world. All of you know and understand what it's like for temperature changes. If a cold front arrived, well, what's happening to your temperatures? Are they going up or are they going down? So what's happening is our temperatures are going down. They're going down every hour. That's what your slope is. So from 67 to 63.5, I'm going down 3, and then I'm going down another 3. So how do we relate that in our equation? We make it a negative 3.5, right? Because every time I add 3.5, because that's basically what I'm doing, I'm adding a number because it's being multiplied. That's what this is right here. So I'm adding something to it. If I add a negative number, it brings it down. If I added a positive number, it would make it go up, right? Makes sense. So this negative 3.5 is my slope. That's the only one that has negative 3.5. Process of elimination gives me D. Now I know I did a lot. Sometimes I may be a little too wordy on these problems, but I hope I didn't kind of muddy up the problem in the way that I showed you how to do it. I just really want you to focus on these charts because they give you missing pieces here. If you go just by the time and the temperature, I feel like you're going to get confused. But I also want you to understand that you take the Y column or the Y row of your chart in any of these charts, the difference between the two numbers, and it's the two numbers in this case we did by hours. Sometimes it'll be by days, sometimes it'll be by months, whatever they are giving you the unit of measure of, that's how you have to do it. From here to here is a 2-hour jump. This is another 2-hour jump. I want these values here and here because they're each 1 hour, 1 hour, 2 hours, 2 hours. I hope that makes sense. Okay. The 67, it's a positive 67, not a negative 67, because that's the temperature we started at. You don't start at negative 67 because that, again, does that make sense that you start at negative 67 degrees and then you keep continuing going down? No. And use that logic as you're going through these problems. Okay. Okay. So I hope that helps. And it looks like everybody is looking okay there. So yes, D is the answer for that one. Okay. So some good word problems. People have been asking for more word problems that you'll see on tests that don't necessarily deal with just numbers and doing the math. So I like to throw some of these in every now and then. It says, after learning the theoretical probability of a two-sided coin landing on any one side, students work in groups to flip the coin several times and get the following results: 9 heads and 6 tails. Based on the scenario, which of the following observations made by students about probability is accurate? So there's nothing going on here where it's giving you an equation to solve or anything like that. It's just telling you theoretical probability right here. So knowing what theoretical probability is and tell me which answer is correct. So you have to go through the answer choices and understand them. It says theoretical probability of a coin's landing on heads, 0.5, is equal to the experimental probability obtained. So here's where we see theoretical probability and experimental probability. And we see it in every problem. I'm sorry, not every problem, every answer choice. So do you know what theoretical and experimental probability are? And this is where, you know, again, I'm going to tell it to you like this. No matter how many questions are on your exam, you know, kind of figure out where your 80% mark is, right? If you have 100 questions, then you want to try and shoot for 80 right. Okay. I know I'm just pulling that out because that's an easy number to work with. You do not have to get 100% on your exams. You are going to see problems like this where they throw in math terms. That's just part of the test specifications, the right nomenclature in math, the right terms. And sometimes we may not study that. It's new to us. We just didn't hit it. So you may need to just take an educated guess. And that goes for all the problems. If you find some hard problems, there are throwaway problems on the exam. Do not think that you need to get 100%. Nobody cares the score that you get on your test. Nobody will ever see the score that you get on your test. Okay. So if this is a problem where you don't know what theoretical probability and experimental probability are, then make a guess and then move on with it. But it's always good to know these terms and be familiar with them. So theoretical probability, I would say it's hard to understand. Theoretical probability is what's supposed to happen, right? So let me just do that. Theory supposed to happen. And then experimental, and please don't mind my writing, but you get the idea. Experimental probability is what does happen. That's the best way that I can make sense of that right now. So in theory, if everything was in a perfect world, if you flip a coin, what is the probability of getting a heads or a tails? Well, if there are two sides, that means whatever I get, it's 1 out of 2, or it's 0.5, 50%. That's theoretical probability. In this case, with a heads and tails. They gave us the experiment. So just think of it like that. Experimental probability is the actual experiment. So what did the actual experiment result? And it says, and you see, looking at this, I see heads, heads, heads. And then that last one, we'll read that last one. So we're looking for heads. So in theory, you have a 50% shot. That means no matter how many times you flip the coin, 50% should always land on heads and 50% should always land on tails. In this case, we had 9 heads. So I got 9 heads out of, not 6. Don't put 6. Okay. Right. We see this 9 heads, 6 tails. It's 9 out of the total amount. Well, if I had 9 heads and 6 tails, 9 plus 6 is 15. So when I figure that out, 9 divided by 15, I get 0.6. Now, obviously, 0.6 is not 0.5. So then as we go through, so answer choice A, the theoretical probability of a coin's landing on heads, 0.5, is equal to the experimental probability obtained. Does 0.5 equal 0.6? No, it does not. So that means A is out. B says the theoretical probability of a coin's landing on heads is less than the experimental probability. If theoretical is 0.5 and experimental is 0.6, then yes, 0.5 is less than 0.6. Therefore, answer B is correct. And I'll just put that there. I'll go through the rest of them just so you see. C says the experimental probability of a coin's landing on heads, 0.6, that's right, we figured that out, is lower than expected. Well, is it lower than expected? If we were going to do this two-sided coin, the expected is 0.5. So it's actually higher than expected. So therefore, that is not correct. And then finally, the experimental probability would have been more accurate if the students had decreased the number of trials. So in each of these answer choices are specific terms that are making them wrong. In this case, the word equal is wrong because it's not. Lower is wrong, so it should be higher. And then decreased. How do we get to a more accurate theoretical probability when running an experiment? You do it many times. There's a difference between flipping a coin 10 times and flipping a coin 1,000,000 times. You will start to see it go towards theoretical probability the more experiments you do. So that's why D is incorrect. Okay, I hope I explained that pretty well there. And again, it's just problems like these where they throw some terms at you and you got to know what the terms are. Okay. Question is from, could we set this problem up as a proportion? I mean, the only proportion you would do, no, I wouldn't, because you're not setting it equal to anything. You are only looking for the experimental probability versus the theoretical probability. And that's it. I don't know what you would set up the proportion as, but yeah, no, I would stay away from that because it's not asking you to solve anything other than give us what each of these probabilities are and then compare them. Okay, next question. So we've got work on a problem. A student simplifies the initial expression by applying the rule of order of operations. Which of the following best describes the student's error when simplifying the expression? So again, when we do these types of exams, a lot of times you'll see student work, and then they can ask you any number of questions relating to the student's work. In this case, it's which of the following describes the error. So definitely made a mistake. Where's the mistake? The best thing to do in these situations is kind of skim through the answer choices first, and I'm looking at the student added before evaluating the student values. So I just want to make sure that there's no numbers or anything involved in that. Then I go up to the problem and I kind of start solving it mentally in my head. So I say, okay, what's the first thing we do? So order of operations, and let's give it to you real quick. So everybody likes to do this. Everybody is very familiar with PEMDAS, I hope. So what I like to do is I do this. I do P for parentheses. Do I need to write it out? Parentheses. E is exponent. And then this is important. MD. Multiplication and division. Here's what's important. Left to right. I cannot stress this enough. And I can also not stress it enough that you will more than likely, like 90% chance that you will be assessed on order of operations in this way, because we are so, we are taught with this PEMDAS like this. That's why I like to do it in levels. So I go P like this, E like this, M or D. Okay. And I know they're not, you can't do anything other than put them next to each other, but just know that it's left to right. And then AS for addition, subtraction. Again, you can say left to right, but it doesn't matter because you can do addition, subtraction either way. But it's very important for multiplication and division to go left to right. So if division comes before multiplication, then yes, you do the division before the multiplication. You read it like you read words, left to right. So there's my quick PEMDAS spiel. So with this, I'm going to look at the parentheses. I see that I can do the 2 and the 6. So I would put these two together. It would be like 3 times 8 and then squared minus 4. And then I go down to the next one and I see I got 3 times 2 plus 3 plus 3 times 6. And I'm like, huh. So, and that's, let me change that. I don't like when they do the old school multiplication. So when you're on your own scratch paper, change it up. Doesn't matter. The old school multiplication X is still the dot. I like the dot because it makes it easier for me to understand. So now I look at this and I see this and it doesn't match. So I say to myself, did I do something wrong? Is there another way that I can do this? And I'm looking, and when I look, I notice what they did is they distributed. So 3 times 2 and then 3 times 6, which, yes, you can do, but order of operations, I gotta knock that guy out first. That guy supersedes this right here, right? Exponents here is definitely more powerful than multiplication, which is below it. All right. So I know that that second part is where we did it wrong. I see that he distributed. Let's go to our answer choices. It says the student added before evaluating the power of the exponents. No, there was no adding involved. Although he could have added in the parentheses, that's totally fine. Make the 2 and the 8 just like I did, but that's not where the mistake was. B says the student evaluated the exponent before subtracting. Well, I don't see anything being evaluated on the exponent before subtracting. That's not what happened, so that's gone. C says the student multiplied before simplifying within grouping symbols. Okay, so within grouping symbols, that's just fancy math talk for our parentheses. This right here represents our grouping symbols, and he multiplied. That means he took this 3 and multiplied it to these before doing the 2 plus 6. And again, that's correct. He should have done the 2 plus 6 and then to the second power, but it doesn't matter. That's where we're going with this one. D says the student simplified the expression from left to right. And again, that's not how it was. So C is the correct answer here. With all of these student work problems, best thing to do is just, again, go right down the problem and match it up like I should have done. Well, you're on your own scratch paper, so you wouldn't be able to do this. So it's easier for me to do it, right? That's why I did the 3 and then the 8 squared and then minus 4, right? So they're all on the same line. So I can see, okay, mine doesn't look like his. And then we go from there. Okay. All right. Okay. So C is the answer. Very good. Okay. All right. So here comes the next one. And I don't want to make you crazy on this one. So just kind of take it for what it's worth. But I did pull this from the released test questions. So it has been on an exam. And it is something that you could see, and it is at the elementary level. So it says in both figures shown, the scales are balanced. Which of the following scales is also balanced? So I'm going to take you on a little bit of a ride for this problem. But again, this is, in my opinion, this is like a literal equation. Literal equations are when you have, and I'll just give you this one, area equals 1/2 base times height. Everything is basically letters. And what if I said solve for B, right? So you'd have to move things around and then solve for B. Well, this is very similar to that, except now we're dealing with shapes. And I also, and I'm sure you've seen it on Facebook, where it shows you the little things where it's like a face and then like a boot and then, you know, like an ice cream cone. And then it gives you the number, 10. And then it'll give you 2 ice cream cones. And that equals 4. Okay. So what you're doing is you're applying your symbols to values. And it's the same thing. It's algebra. That's all it is. So within this, you have to figure out how to work this out. Now, again, if this is a problem that you look at and you're spending too much time on, give it a guess and move on, because we don't have to get every single one right. And I'd rather spend my time on something that I can do. Can you use the formula? Okay. So what this means is these scales are balanced, which means they're equal to each other. Okay. So you can use anything that you see in order to get the answer A, B, C, or D. So here is what is important for this. Do you see how this is 1 right here? And if these scales are balanced, wouldn't this be an equal sign, which means this is an equal sign as well? Okay, we get the picture. So now I'm going to try and use my best artistry. If one triangle is equal to a cylinder and a cube, that means I can substitute anything for a triangle as a cylinder and a cube. When I do this, so I'm going to substitute this in. I now have, and I'm going to just do a cube like that. I'm not going to put triangle, right? I'm just going to do cylinder. I'll put it in parentheses. Cylinder and another cube like that is equal to 2 cylinders. Okay. So now square, square, cylinder is equal to, and let's make sure I'm doing this right here because I don't want to confuse anybody, because I'm sure you're already confused as it is. Okay. And so this comes out. So I just put the parentheses there just to show you that that triangle went in there. So now, again, just like math, right? If I have the same value, now look, I'm not multiplying, I'm not dividing, I'm not doing anything else. I just have a square, a cylinder, and a square, and then 2 cylinders here. Well, what do you know about balancing equations and doing all of that type of stuff? Do you see how I have something that is the same on both sides? If I have something that is the same on both sides, that's 1 cylinder here and 1 cylinder here, then they cancel each other out, right? Doesn't that make sense? It should make sense. If I were to pick up these objects off of this scale, would it go either way? No, because they both equal the same amount. They're the same exact thing. So when I do that, okay, now stick with me here. I am now at 2 squares or 2 cubes are equal to 1 cylinder. Okay. So if I know that 1 cylinder is equal to 2 squares, okay, then I can look and I can say to myself, all right, I can input any cylinder with 2 squares. So what can I do with what I already have to make these, or find which scale is the same thing? So again, we're looking at these up top. So let me erase this. So I understand what I've done. I've taken my triangle and I've put it here because I know triangle equals cylinder square or cube. So when I do that, I have cube, cube, cylinder, and then cylinder, cylinder. Cancel those out. 2 cubes equals a cylinder. Clean this up so that you don't get confused here. So now how can I substitute, because that's what we're doing. How can I take my 1 cylinder and put it in here or put it in here and get one of my answer choices? And the one that I saw that jumped out right away, if I substitute this right here, I end up with, right, 2 squares. So that goes away and I get 2 more. And you see how I have 3 squares for 1 triangle, and I got 3 squares for 1 triangle. And that's what the answer is. And I know you're probably like, what in the world? But that's why I pulled this, because there is the opportunity that you will see a problem like this. So you have to be able to go ahead and solve it just like you would solving algebra. And I know it probably makes your head hurt and your eyes are like confused, but again, I know it sounds weird, but this is math. This is all we're doing is just moving values around, substituting, eliminating if we have to. Yeah, it's a funny comment. And just figuring it out. The goal in this case, I'll tell you right now, the goal is to get it to a single value. I was able to have this triangle equal to a value, but see how it's single, it's 1. And then as soon as I got to this next part where I eliminated this, I got to a single value here. And with those single values, you can always substitute a single value. So in any problem like this, if this comes up, always find a single value. And it's the same as saying, you know, let's just say the other one was 2x plus, or 2x. No, I don't want to do that. Yeah, 2x plus, and again, this is nothing to do with these, but I'm just trying to, 2x plus 3y, equals 10. And then on my other one, I had x is equal to 2y's. See how this is a single value? This single value can be easily substituted into this equation, allowing me to solve it. So that's why it's important. Single something out and then single something out on that next part. Okay. I don't want to spend too much time on this one, but if you need to go through it again, you can go ahead and rewind it on the replay. But yeah, that one was totally crazy. That's why I picked it. All right, little bit change up. We're going to do some radicals. And again, this is very simple radicals. So which of the following is equivalent to 2 square roots of 3 and then times the value square root of 2 plus square root of 3? So now, what's the deal with roots? So if you are doing on scratch paper, which you should be doing, we have 2 square roots of 3 and then times the square root of 2 plus the square root of 3. What are our rules for roots? So going through, I've got parentheses, which means I should do inside parentheses. If I have a square root of 2 plus a square root of 3, can I just add those and get square root of 5? No, you can't. Please don't do that. Square roots are very similar to, let's just say, like variables. And so how can I do, like if this was a plus b, can I do a plus b? No. Why can't I do a plus b? Because they are not like terms. The same thing applies for radicals. You cannot do addition or subtraction unless they are the same radical. Okay. So please do not add that and get a square root of 5. You cannot add these because they are not like terms. So now we need to go outside and we're going to take this value here. If I don't have the eraser on, we're going to take this value here and distribute it to each one. How do we distribute it to each one? Just like you would do anything else. So I'm going to do it the long way. All right, good question. Could find the square root of each. Do not find the square root of each. You're going to get some crazy decimal numbers. And then once you get those numbers, you're going to look at your answer choices and you're going to be like, that doesn't work out. How do I do that? Because then you're going to be taking the square root of each answer choice. So you can do it that way. It's a longer process. It's a very tedious process because you're going to get a bunch of crazy numbers and it's not the best way to do this problem. So I need to go ahead and distribute. That means this to this is going to be 2 square roots of 3 times square root of 2 plus 2 square roots of 3, terrible 3, sorry. And then times square root of 3. Now, how do we multiply roots? When we multiply roots, you are allowed to take each of those roots and multiply them by each other. So this becomes 2 square roots of 3 times square root of 2. Again, I'm doing this the long way. You shouldn't be doing this. I'm just trying to show you what happens so that you will be able to do it a lot faster and with less writing. That comes out to 2 square roots of 6, right? 3 times 2 is 6, but keep it under the radical. Same thing here, 2 square roots of 3 times square root of 3. That's 2 square roots of 9. So then these are being added to each other. Now comes simplifying. Can we simplify 2 square roots of 6? No. Can we add 2 square roots to 2 square roots of 9? No, they're not the same. Then we look at this one. You notice anything crazy about square root of 9? If you don't, and this is what you should always do when we're simplifying radicals, kind of put it in if you don't know them already, but know your perfect roots. Hopefully you do. If I did 9 square root, I put it in my calculator, I get 3. So if this comes out as 3, then your number comes out to the number on the outside. It should be 2 times 3, which is just 6. So I've got 6 here. I've got 2 square roots of 6 here. They're supposed to be added. I know there's a bunch of stuff here, so let's do this. Let's just, you know that that's supposed to be 6. So 2 square roots of 9 is actually the whole number 6. And with that, can I do 2 square roots of 6 plus 6? No, because remember, not like terms. Why are they not like terms? Because this one has a square root of 6 on it, and this one doesn't. So we look at our answer choices, and C is the correct answer because we can't. That's as simple as it can go. That is your answer. Okay. So if you did do it where you figured out what each of these square roots were, and then you end up with some decimal, well, you're going to get confused because you're not going to get, it's 2 square roots of 6, which is a certain decimal, and then plus 6. So it's like, it's just a lot of work. Don't do it that way. Do it this way. Again, I pulled this problem simply because somebody wanted radicals, and this was a good way to show you cannot add them unless they're the same, right? Because they got to be like terms. Multiplying them, you multiply radical to radical, and then always look for your simplification, right? That was square root of 9, which is equal to 3. Anything that comes out always gets multiplied to the outside number. Multiplied to the outside number. So C is our answer there. Okay, good. Let's kind of move it along a little. Next problem, we have the old classic with the figure. And I chose this one for a reason. Again, at a certain time of day, student measured the height of the shadow of a yardstick held vertically 5 feet. At the same time, the student measured the length of the shadow of a tree, 26 feet. To the nearest foot, what is the height of the tree? Do you see how they even put everything on here? So I don't know what height is. I'm gonna put an X here, but I've got left side and bottom and left side and bottom, all of a triangle, just like this, right? Everybody sees that. So we can do a proportion. So we like to do here what's called matchy, matchy. So what does that mean? I'm going to take the values and I'm going to assign them so that I either do all small or all big triangle. I can do left side and do big, left side big, do all left side over the bottom values. So that's what I'm going to do. That's how I see it. I see it left over bottom. And what I mean by that is setting up my proportion on the left side. So I'll do small first. The left side of the small is 3. And then the bottom is going to be 5. So that's all relating to the small triangle, which means I can do in the big triangle. I don't know what the height is or the left side is. but I do know what the bottom is, and it's 26. So then how do we solve these proportions? You're supposed to cross multiply and divide. The way that I do it, and I encourage you to do it, because again, we're writing down everything on scratch paper. We want to try and write as less as possible. In order to write as less as possible, we got to kind of skip through steps and only write what is needed. Use your calculator. I would say pick up your calculator. So you pick up your calculator at this point and you multiply the only two numbers that go diagonal with each other. So I'll write it down. It's 3 times 26, but in the calculator, I've got 3 times 26 and I hit equals in the calculator. So when I hit equal in the calculator, it's in my screen. I don't have to write anything else. Well, this is 70. It's, I'll write it down so you can see it. So this is equal to 78. Okay. So I've got 78 is equal to 5x, but I know I'm supposed to cross multiply and divide. The 78's in your calculator. Don't write anything down, not necessary. Just hit divide, and then the only other number that's left, which is this 5, and hit equals, and you've got your number. You know, it was divide 5, and we've got x is equal to 15.6. And that's it. It's in your calculator. It's done. It's ready to go. You don't have to do any more writing. Just go straight to your answer choices. Now, it said to the nearest foot. So that's why we get 15.6. Let me clean that up. That's a bad 5. That's even terrible. 5. 15.6. What number is closest to 15.6? And again, that's why estimation is so good on this test. If you can get really good at estimating your math, 16 is closest to 15.6. Obviously, nothing else comes close. 16 is your answer. That's how you do it, setting up a proportion. But here's what I want to show you as well. I want you to take note of all these little things because it can help you. The reason why they give you these is because these are proportions. Proportion means so many times bigger or so many times smaller, okay? If I have this at 3 feet and this at 5 feet, I've got no value for these two to work off of, the 3 and the nothing, but I do have this 5 and this 26. Proportion should always mean to you, again, like I said, how many times bigger? Well, if I got to make something bigger, I'm going to multiply that number. Okay. If I'm going to make something smaller, I'm going to divide it. When you think proportion, I always want you to think multiply or divide. Okay. So how can I get, so I've got 5. Let's just do this. You always work with the values that you have. If I have 5 and I want to go to 26, I say going from 5 to 26, am I going up or I'm going down? If I go up, that means multiply. So what can I multiply by 5 to get to, 26? Well, again, if we are estimating, right, nearest foot, and I'm telling you, try to use estimation. I have to go 5 times 5 gets me to 26. 5 times 6 gets me to 30. So it's roughly times 5. That means because it's a proportion, if I do one side by 5, I have to do all sides by 5. So let's take our 3. What is 3 times 5? And it's equal to 15. Well, roughly speaking, because I'm telling you, use your estimation, 15 is in the ballpark of which of these answer choices, and see how it's 16 still works just by estimating like that. That's a good tool to have when we're dealing with proportions. And it's not necessarily just on shapes like this. I chose the shape just so you could see, because I feel like that triangle is better. But if you're getting proportions where it's like, measurements for a recipe or boys versus girls in a class, you can use the same exact concept. So I just wanted you to know that the same thing applies for, the opposite. If I'm going backwards, I would be dividing. This is a tougher one, but 26 divided by what number will give me 5, and can't really divide anything by 26, but it's a little more difficult if you had to go the way that you feel more comfortable. Usually multiplying is a lot better than dividing, but it would be divided by 5. So what number divided by 5 gives me 3? And you would say 15. So, but use the multiplication one. I feel like it's a little bit easier. Okay. Here is the next one. I've got, let ABC be a triangle with a leg AB length of 4 and leg BC be a length of 8. For which of the following possible lengths of hypotenuse AC is ABC an obtuse triangle? Okay, seems like a lot. So with this ABC, we've got random ABC. So I'm going to just draw random ABC triangle A, B, C. I know this is my hypotenuse right here because it's the longest side, or at least I drew it that side, but honestly, you can put ABC anywhere and it doesn't matter because I've already told you in the problem, hypotenuse is AC. So it says AB a length of 4 and BC a length of 8. And then I need to get an obtuse triangle. Very important here. What is an obtuse triangle? So acute and obtuse are our two terms that we do. This is, I am less than 90 degrees, and this is greater than 90 degrees, okay? So I need to know that it's greater than 90 degrees. So how in the world can I figure out what's greater than 90 degrees? Well, if I have a triangle with the legs of 4 and 8, and I make it a right triangle, how can I figure out what the length of the hypotenuse will be? And I can use the Pythagorean theorem, because I know that if I find where 90 degrees is, obtuse means I have to be greater than 90. And when I find out whatever this number is, the only way that it can be obtuse is if this number is greater than, oops, no, that's not right. That's weird because it's not going to work out. Oh, shoot. It won't work out correctly the way I wanted to draw it. Sorry. But whatever this value is here is going to be greater than in order to be obtuse, right? So I'm going to find a value for this X, and that X says I'm a 90-degree triangle. So I have to be bigger than this number in order to be obtuse. So let's go ahead and figure this out real quick. And it'll make sense once I figure it out. So I'm going to do Pythagorean theorem, which is a squared plus b squared equals c squared. Again, you can do this in your head. You can do it in your calculator. You can do it many different forms, but I'm just going to throw it out real quick. So I've got 4 squared plus 8 squared equals c squared. Here, let me do this. Let's just make that c. So I've got 16 plus 64 equals c squared. Add them up. I've got 80 is equal to c squared, square root, and it's like just below 9. 80 square root 8.9 equals c. Okay. So here's where this problem gets tricky, because if you look in the comments, I see someone says, I tried to use Pythagorean theorem, it didn't work. Well, Pythagorean theorem does work. When this is a right triangle, right? What are the properties of a right triangle? You have 90 degrees here, and that means it's just a right triangle as it is. So 8.9 is going to be a right triangle, a perfect right triangle, give or take, because it's not a perfect square root. But for the purposes of this question, 8.9 is a perfect right triangle. I need to find what will make it obtuse. That's the question. It says, which of the following possible lengths? So I'm not looking for 8.9. I'm looking for anything greater than 8.9. Does that make sense? So obtuse, I can't write it as a like 8.9 greater than. Just know that 8.9 has to be the limit. It's got to be greater than 8.9. So 5 doesn't work, 7 doesn't work, 8 doesn't work, right? So the only one it could be out of these right here, out of these possible answers, is 10. So 10 is the answer, because if AC had a length of 10, then it would be an obtuse triangle. Does that make sense? Because it would open up a lot wider. It would not be 90 degrees. It would be greater than 90 degrees, thus giving us an obtuse triangle. It can be 24, it can be 106, but just understand that, well, actually it can't be that, but just understand it has to be, you know, what they're giving you. There's 4 choices, which one could be a possible length, and 10 could be that length, because we know 8.9, it's got to be greater than. Okay. All right. And then the last one, and I always like these just because I was always teaching geometry, so I love these types of problems. I feel like these are more like riddles. So it says, in triangle ABC shown, AB equals BC. The measure of angle ABC is 30 degrees, and line segment AM is perpendicular to side BC. What is the degree measure of angle MAC? So I'm going to give you all the goods on all these geometry terms that they're giving us. We'll start out with this. ABC, AB equals BC. If AB equals BC, right, that means that 2 sides of a triangle are the same. We put these little congruent marks here. When we have 2 sides of a triangle that are exactly the same, what type of triangle do we have? And we have an isosceles. Okay. So that means if I'm isosceles, we'll start out with this. I have 180 degrees. There's always 180 degrees in every triangle. I'm taking this big triangle ABC. I already have 30 degrees, right? That's where that comes in. I've got 30 degrees already. So I take that away. I have 150 degrees left over to place into these 2 angles here. I now divide it by 2, because in an isosceles triangle, base angles are the same. Sides are the same, base angles are the same. So now that I know that, when I divide it by 2, I get 150 divided by 2 is 75. So now that I know that these are 75, I'm going to put 75 right here. Okay. So now I know that's 75. And again, we're looking to find MAC. So that's this little guy right here. That's what we're looking for. If this is 90, right, and this is 30, well, if I have, and again, I'll do it over here. I've got 180 minus 90 equals, oh no, why did I do that? Sorry. 180 minus 90, which is the 90-degree angle, minus another 30, right? 90 and 30, that's going to give me 60. So this angle right here is 60 degrees. So 30, 60, 90, that makes this angle, so, or triangle. So you have, this is all one triangle. So we have to have every triangle in here equal 180 degrees. 30, 60, 90 equals 180 degrees. That entire triangle is solved. So when I go to this one, if this is, I know it's small and it might be hard to see, but if this is a right angle and they told me that this is perpendicular, perpendicular means intersects at a 90-degree angle. Well, then I go ahead and I carry this over here like so. So this is 90 degrees and this is 90 degrees. So I'm going to go ahead again and find out if I ever have 2 out of 3 angles in a triangle, I can always find the third. I have 90 and I have 75 here. So what I'm going to do is 180 minus 90 minus 75. And that gets me, that gives me 15. So 15 belongs right there in that angle that we were looking for all along. And B is the correct answer. This is good because you need to know triangles in 180 degrees. This may be a little more, although I did pull it from elementary. So, you know, it's fair game. Just know that every single triangle has to equal 180 degrees. And the reason why, so you've got this, you see it here because I'm going to erase it. I'm going to show you some things, but you have to know the properties, especially the isosceles one. The isosceles one gets everything started. And you've got to be careful because when we did the isosceles, we found out 75 here, but this whole angle is 75, right? The problem is this is broken up into two, which is why you have to kind of solve the first two triangles to get to this third one. So please be careful that you don't say that this angle is 75 because see, they give you 75 as a possible answer choice. This line that separates it breaks that 75 up into two different angles. Okay. Yeah, I think that's about it. And then the perpendicular means that this line goes through and creates 4 90-degree angles. All right. Okay. So that's it. All good. Last slide is always the answer key. Got to have our answer key. And that's it. Wow. Time flies when you're having fun. That was a little over an hour. Okay, good. All right, let me double check because I was only on the YouTube. I was kind of flying by here. I hope everybody was good. If you had any questions on the Facebook, give me a second. I'll give everybody a chance to kind of regroup. And if you have any questions, throw them in the chat and I can answer them. Oh, geez. Any depth of rock questions? Hello. What is depth of rock? If you didn't get number 3, kind of look over it again on the replay. If not, take that question as the one question that you're going to throw away. It's good if you understand it. You know, that was this. Oh, I'm sorry, not number 3. That was number 3. I'm talking about crazy number 6. Crazy number 6 is nutso. But number 3 was just understanding that you have these points and it's very difficult with the points because they're using time. You know how you're supposed to take 2 reference points and then that'll be, well, let's see here, 263 to find your, not your slope, but your, yeah, your slope. Don't worry about it. I'm sorry. I'm just kind of mumbling here. Yeah, someone's asking for a depth of rock question. I don't understand what that one is, but you can email me if you figure it out and then I can help you out for sure. But it looks like everybody's comments good. We're good to go. If you have anything, if something comes up, okay, info at Kathleen. Sorry, guys. I'm about done with the pen today. KathleenJasper.com. Okay. Info at KathleenJasper.com. You will get me there. They always forward all the math stuff to me. Send your screenshots, send a description. I know you sent the description with the rock problem, but I don't understand that. So be a little more specific if you can. And I will try and put those questions up for you. I hope I helped you out today. I hope you learned at least something. If some of them are confusing, then they're confusing. Try and find some on the internet, find some more practice problems, kind of understand the concept that I was going over. And then we can look at it that way. On question 6, why is this formula? You see. No, don't. Okay. Look, I put this here because I wanted you to understand that you're looking for a single variable, which is what we were doing here. Singles substitute well into singles. It has nothing to do with this problem. I was trying to show an example. Okay. So the reason why I was able to take this triangle here is because it was one single triangle equals that, which gives me some more values here. I can't do that with anything else because there's not, I can take two circles, right? But what can I substitute in for two circles? Nothing. So even if I looked at it, two circles goes here, but it doesn't have a triangle with it. So that doesn't work out. Okay. And so on and so forth. But that's the only reason why I had that equation there. That was just an example. Okay. All right. So that's the address. If you need anything, send me your stuff. Other than that, I know it's first week of June. We passed our July 30 deadline. A lot of you may not have gotten the test scores that you needed, and that's okay. Just keep trying. Otherwise, those of you that are going into your, I don't know how it works in some states, but if you're in Florida, your third year of eligibility, then make sure that you are getting these certifications out of the way. Get them out of the way in the next month before school starts, and then you don't have to worry about it. You can worry about everything else, your classroom, all that stuff, but get these certifications out of your way. And like I say, I'm here every Tuesday to try and help you out, doing the best that we can to get you guys through these math tests that are so frustrating for you. So hit us up on all our major socials, Facebook, YouTube, Twitter. I think we got Instagram. I'm sure we're on the TikTok and all that stuff. So if you need anything on websites, KathleenJasper.com, we offer a lot more than just doing the math, but I'm here every Tuesday for you. And that's it. Hope everybody had a good holiday weekend. Get back into the swing of things here soon. Enjoy the rest of your summer. And I'll be here next Tuesday to see you guys. And hopefully you'll be joining me. So have a great week, everybody. I will see you next